Hello, welcome back everyone. So in this session we are going to deep dive into the four pillars concept of the object oriented programming in the Java. So these concepts aren't just theoretical, they are the backbone of the real world automation framework also. So nowadays when you go for test automation interviews, you will always face this question. Okay, so you need to explain or you need to define this concept first, and you need to provide some example where exactly you have used this concept in your automation framework. So encapsulation, inheritance, abstraction and polymorphism. These are the four pillars of the object-oriented programming. So using all these four concepts, you will be able to create scalable and maintainable and highly performance Java applications. And at the same time, we can use all these four concepts to create a robust automation framework. So let's start with our first concept, that is encapsulation. So in the interviews, they can ask you what is the encapsulation and how we have used encapsulation concept in your Selenium automation framework. So first you can define the encapsulation concept. So encapsulation means hiding the internal details of the class and only exposing what is necessary through our public methods. Okay, so encapsulation concept will help you to hide internal details of the class. Okay, so in simple words, it's like wrapping the data members and code together and protect it from the outside access. For example, here we have created one class and here we have added some variables and methods in the same class. So this is what we are wrapping the data members together. So every Java class that we create is the example of encapsulation. So how we are going to protect the data members from the outside of the class? So simply we can create one class. For example, here we created one class and we defined the variables as private. So these private variables we cannot be accessed from the outside of this class. Those can be accessed within the same class only. So if I want to access these variables or if I want to set the values for these variables, I will have to create some public getter and setter methods. Okay, so direct access or updating the values of these private variables is not possible, and that is what we have created using this encapsulation concept. So in our automation framework, where exactly we have used this encapsulation? So as per the page object model, we create separate class for each page in our Java application, right? So for creating the page classes, in that class we write our web element locators as private, because all these locators will be used in the page class only. We are not going to directly access these locators from the test classes. So for that purpose, we make our locators as private, and whatever actions or page actions we are going to perform, those methods we will make as public. Example, here we have created public class login page. So in this login page class, I have created two web elements. One is username field and password field. So both these variables, both these locators are private only. Then I created one action, login action, which will be used all these locators. So this action I am going to directly call from our test classes by creating the object of this login page class, right? So I cannot directly access these web elements from the test classes. So this is the example of tightly encapsulated class in the Java. Okay, so when you make all the data members or all the variables as private in the Java, that class is called as tightly encapsulated class. So in the tightly encapsulated class, where all the variables we make as private, and those variables can be accessible via public getter and setter methods only. For example, here I created user data public class. So inside this class I created username and password string variables as private. So if I want to set the value of this username and password from the outside of this class, I will have to create public getter and setter methods. So public string get username, this method is going to give you the value of username. Okay, we have written the username value. And if you want to set the value of username, then we need to create public void set username method. So this method will accept username as a parameter, and whatever username value you will pass from the outside of the class, that value we will going to assign to our current class username variable. Okay, so same approach, getter and setter methods we can use for getting the value of or setting the value of password field. So this is the example of tightly encapsulated class in the Java. Now let's move to our next concept, that is inheritance. So by using inheritance property, that will allow you one class to reuse the properties and methods from the another class. Okay, so this property or this feature of the Java will help you in avoiding the code duplication and supports code reusability. So for achieving the inheritance, you will create two classes. One is parent class containing some methods and variables, and another child class which is going to extend this parent class. So all the methods and variables from the parent class are accessible for the child class with the inheritance property. So for that, we need to use this extend keyword. So once you extend any class from this parent class, all these methods and variables we can directly access in that child class. So where we can use this inheritance concept in the automation framework. So whenever we need to open the browser, we create setup method where we open the browser and perform login also. So this setup method we can add in parent class, and also for closing browser, that is tear down method, also we add in our parent class. So all these two methods we don't need to create in our child classes. So our base test class will be acts as a parent class, and all other test classes will be child of this parent class. So this login test is nothing but the child of the base test. So I don't need to create this setup and tear down method here. So I will directly use, let's say I am going to test the login. So I will directly create @test public void test login method. So inheritance nothing but your parent child analogy. So whatever methods you are going to reuse again and again in other classes, all these methods or all these reusable methods you can keep in the BaseTest or parent class. So now next feature is abstraction. So abstraction means hiding the complex implementation details and showing only the essential features to the user. Okay, so using this feature we will be able to make our code more cleaner and easier to use and modify it. Okay, so we are going to show what exactly we can do, but we are going to hide how we have implemented it. Okay, for example, in the ATM we directly withdraw the cash or check the balance, but we don't worry about how those implementation are done internally, right? So whatever options we have provided in the UI, we only use those options, and using those options we will be able to perform actions in the ATM machine. So abstraction in the Java can be performed by using two options. One is interface concept and another one is abstract class. We can create abstract class in our automation framework. Let's say you create one abstract class DriverManager. So in real-time automation framework, we can run our automation on the local machine or on our remote machine on the AWS or Docker Selenium grid. So for that purpose, we will require local driver, that is Chrome driver, Edge driver or a Firefox driver, or we will also require remote web driver to run it on the remote machine. So here we can use the abstract class concept. So let's say I created one public abstract class DriverManager. So this class contains protected WebDriver variable and one abstract method getDriver. So this getDriver method is an abstract one. So as it is an abstract, we are not going to provide any implementation. So this method implementation should be done by the child class, which are going to extend this DriverManager class. So for implementing this abstract getDriver method, we created two child classes for this DriverManager class. So one is local driver manager and another one is remote driver manager. So local driver manager is going to create the object of Chrome driver or Edge driver or Firefox driver whenever I want to run my automation on the local machine. And remote driver manager class, which is also extending this driver manager, going to create the object of remote web driver class. So whenever I want to run the automation on the remote machine, I will be calling the object of this remote driver manager class. So provide implementation for this getDriver in the local driver manager class, which will open the Chrome driver, and implement this getDriver in the remote driver manager, which is going to create the object of remote web driver. So this is how we have used the abstraction concept in our automation framework. Like this you can explain. So first tell the definition of the abstraction. That means hiding the complex implementation details and showing only the essential feature to the user. And then explain where you have used this abstraction concept in the automation framework. Like we use the abstract driver manager class to define method like getDriver, and let the child classes like local driver manager and remote driver manager to implement it differently. So now let's look at our last concept in the 4 pillars, that is polymorphism. So poly means multiple forms. So polymorphism means one thing behaving in different ways. So in the Java we can create multiple methods with the same name, but these methods are going to behave differently. So this can be achieved by 2 ways. One is overloading and another one is overriding concept. So overloading is nothing but the compile time polymorphism, and overriding is nothing but runtime polymorphism. So first let's see the method overloading. So method overloading means defining the multiple methods with the same name but different parameters. So these parameters type can be different, or different number of parameters, or their order should be different. Then only we can say that method is a overloaded method in the same class. So let's see the basic example. Let's say we have public class calculator. So this calculator class going to have some methods for addition and subtraction. So let's say I created one addition method, public integer add, which will accept 2 parameters, integer a and integer b. So this method will be used to add 2 integers, a and b. So it is going to return a plus b. Then another method I created for addition of 3 integers, public integer add, integer a, integer b, comma integer c. So if you see here, the method name is same, add, only the parameters are different. So in the first method I have 2 parameters, in the next method I have 3 parameters. So this is the example of method overloading. So I am using same method name but different parameters. Okay, so like this you can create multiple addition methods for integer addition, or if you want to add the double values, you can again create public double add in the bracket double a comma double b. So here by using this add method I am adding 2 double values. So return type can be different, return type can be same or different. Only condition is method name should be same and parameter type or their order or number of parameters should be different for overloading. So where we have used overloading concept in our automation framework. So in the automation framework we read our test data from the Excel or CSV files, right? So sometimes we need to read a single cell data, right? Sometimes we need to read the entire row data or entire column data. Sometimes we need to read all Excel data. Okay, so for that purpose we can create a single method, read Excel data, and this method can accept different parameters. Okay, so one method to access, let's say a cell, you need to pass row number and column number. When you are on to read the entire Excel, you will pass our Excel name only or sheet name. Okay, so method name will be same, read Excel data, only parameters will be different. So this example you can tell. Similarly, another example you can give for pressing the keyboard keys. So like this, we have created 3 overloaded methods. To press only enter key, to press enter on some web element, or to press Ctrl A or Ctrl V by using this third method. So now let's look at the method overriding in the Java. So method overriding means providing a new implementation for a method in a subclass that is already existing in the parent class. So it is going to happen at the runtime, and that is why it is called as a runtime polymorphism. So at the runtime, Java will check which object we are creating. If it is child object, then call the overridden method from the child class. If it is not, then call the method from the parent class. So let's see a basic example to understand the overriding. So let's say in the banking application, depending upon the bank, you will have the different interest rate or your FD or your saving account. So let's say I have one class bank, and this class contains get interest rate method. So this method is going to return by default 5.0 interest rate, which is a double. So return type is a double. Now SBI, HDFC or ICICI Bank will offer you different interest rate, okay, as per their policy. So we will have different child classes for this class bank. So let's say I created one class SBI extends this bank. So this class will going to override this get interest rate method because it is going to implement differently. Okay, so whenever child is not satisfied with the parent class implementation, it can override that method in the child class. So how we can override? Again, you need to implement that method. So here also condition is your parameter should be same and your method name should also be same. So here I am writing double get interest rate and I am going to return 6.5 value. Okay, so in case of SBI you will get 6.5. Again, another child we created SDFC. So class SDFC extends bank. Again, it is going to override this get interest rate method and it is going to provide you return 7.0 interest rate. So this is how we can override the method from the parent class in the child class by using the same method name and same parameters. Only implementation is different. So for calling this get interest rate method, I created first bank reference. So bank is our parent class. So I am using that reference only. Bank reference, bank is equal to new SBI. Now using this bank, I am going to call this get interest rate method. Okay, so now reference is parent bank, but object is of SBI class. So at the runtime Java will check we are creating the object of SBI. So it is going to return you the interest rate from the SBI child class, not from the bank class. And that is where overriding comes into the picture. Okay, so here you will get 6.5. Again, using the same reference, bank is equal to new SDFC. So here I am creating the object of SDFC class now. So again at the runtime it is going to check that object is of SDFC. So it is going to check if SDFC class contains any get interest rate method or not. So if it is there, it is going to call that method from the SDFC class instead of calling from the bank class. So again here you will get the 7.0 interest rate. Okay. So in this example, our method get interest rate is a overridden method in the SBI and SDFC subclasses to return their own interest rate. So even though we are using the parent class reference bank, the overridden method in the actual object like SBI or SDFC class, it is going to check at the runtime, and that is why we called it as a runtime polymorphism, which is a overriding. So in case of overriding, there will be 4 combinations. Which reference you are creating and which object you are creating. So depending upon the reference and the object, your method access will be provided by the Java. So first is parent reference, parent object. So if you are creating the parent reference and parent object, we will be able to get the basic access to the methods from the parent class only. Okay, so using the parent reference, you will be able to call methods from only the parent class. Okay, so this will not involve any overriding. So let's say we have this parent class. Inside this class we have one method m1 and we are just printing m1 method from the parent class here. Then we created one child class, child, public class child, extends parent, and here also we are overriding that method. So m1 again it will use the same parameters. Here we are printing m1 method from the child class. So let's say in the main method I am creating parent object equal to new parent. So now reference is parent and object is also of parent type. So in this case you will be able to call m1 method from the parent class only. Okay, so in the output you will get the m1 method from the parent class. So using the parent reference you will be able to call only the parent class methods, not the child class. Okay, so here overriding is not involved. Okay, so let's say if child contains let's say m2 method, using this object reference you will not be able to call this m2 method. Okay, so this is the first combination, parent reference, parent object, that is going to give you the basic access. Only the parent methods can be accessible. Then another one is child reference and child object. So using this combination you will be able to call the methods from the parent class, also from the child class. That means you will get the full power. All the methods from the parent and child will be accessible. So let's say again here we have the public class parent. So using this child reference, when you call m1 method, this m1 from the child class will be executed. And using this child object, we will be able to call any other method from the parent. Let's say parent contains m3 method. So using this child, I will be able to call that m3 method as well by using the inheritance concept. So just before we are seeing, using the parent reference, you will be able to call methods from the parent class only. So let's say here we are calling the m1 method by using this parent reference. logically it should call the M1 from the parent class, but that is not going to happen here. Java will check at the runtime which object we are creating. So here we are creating the object of the child class, right? So first it will go into the child class and it will check if M1 is overridden or not in this child class. If it is overridden, then it will give you the preference to the M1 from the child class. And here in the output you will get M1 from the child class, and that is where overriding is happening. Okay, so instead of M1 from the parent class, we are calling or we are executing M1 from the child class using the parent reference. Okay, so this is the heart of method overriding. Method is called depending upon the object, not the reference. And fourth combination is child reference and parent object. So here this combination is not allowed in the Java. Using the child reference, you cannot hold the object of the parent class. Okay, so this is not allowed. You will get the compile time error. Okay, so as a summary, if your reference is parent and object type is also parent, then you will be able to call the methods from the parent class only. There is no overriding. The second one is reference type child and object type is also child. You will get full access to the child methods as well as parent methods. And third type, reference type of parent and object type of child. So here overriding will happen. So you will be able to call the overridden method from the child class. Fourth combination, child reference type and parent type of object, which is a invalid. So your program will not be compiled. So this overriding concept we can use in our adoption framework also. Just before we have explained about the DriverManager class. DriverManager is our parent class which contains getDriver. Okay, getDriver method. Now this getDriver method from the parent class we have implemented by using the two child classes, local DriverManager and remote DriverManager. So now to call this getDriver method from the child class, I need to use the overriding concept here. So first I will use the parent reference, that is DriverManager. Manager is equal to object of the child class, right? Parent reference and child object. That is where overriding is happening. Okay, so as per this concept, I will create DriverManager manager equal to new remote DriverManager. So manager dot get driver. So when we call this getDriver method using this manager reference, Java will check we are creating the object of remote DriverManager. So the method from the remote DriverManager class will be called. So this getDriver method is overridden method in the remote DriverManager class. Okay, and for the invalid case, we cannot create a child reference with the parent object. For example, I cannot write remote DriverManager manager equal to new DriverManager. Okay, so this is the invalid case. So as a summary of this session, we have seen the four pillars of the Java containing encapsulation, inheritance, abstraction and polymorphism. So using the encapsulation, we are going to hide the internal details. So in the automation framework, we have created the page classes containing web elements and page actions using the Java methods. So this example you can explain. In case of inheritance, we are going to reuse the logic and methods from the parent class inside the child class directly. So that is a parent-child combination. So in the framework, you can give the example of the BaseTest class. Then abstraction, that will be used to hide the internal complex programming or implementation. For example, ATM. So in the automation framework, you can give the example of the DriverManager class. And polymorphism, which contains one method and different behaviors. So you can provide the reading the data from the Excel by using the get Excel data method containing different parameters to read the entire Excel or only the row or only one cell. Or another example you can give for pressing the keyboard keys, single key at a time or multiple keys at a time. So that is all for this session, guys. I hope this session will help you in understanding these four pillars of the Java and help you in the interviews as well. So thanks for watching, guys. I will see you in the next video soon.